Hello Gators, this is 8.9 volume with disk method revolving around the X or Y axis and volume with washer method revolving around the X or Y axis. Let's take a look at this problem. Y equal to X squared, Y equal to 0, and X equal to 2 are going to be the boundaries of our area. Let's take a look at this picture. So the black represents the boundaries for the area, and we're going to take this area and we're going to revolve it around an axis. We're going to revolve it around the x-axis. Let me show you what that looks like in an animation. All right, so here's our y equal to x squared and our boundaries here. The area is, I'm using some rectangles, and what I'm going to do is I'm going to take those rectangles and I'm going to spin them around the x-axis. And when I spin them around the x-axis, it's going to create a volume. Now, the more rectangles I get in the spin, the more and more it has this look of a cone going up to the very top. Not truly sides that are lines, a curve, but it has that kind of look. All right, let's go back to our problem here. And now that we understand that this little piece right here, when it revolves, will create this disc. And this disc is a little cylinder. And a cylinder is the area of the base times the height. We're going to call it the area of the circle times the thickness. And the thickness here will be delta x. Okay, let's go ahead and set up the problem. So we have delta v. And we are going to write pi, and our radius will be y of the upper minus y of the lower, and it's going to be squared, and then delta x. Now the y of the upper is this, our parabola, so this will be equal to pi, and then this will be x squared, and the lower will be 0. I won't bother writing minus 0, and then delta x. Now we can set up our volume, and our little delta x's are going to go from 0 to 2. And if you want to simplify this and just write x to the 4th, that might not be a bad idea. And so here's the setup for the volume. And that volume will have that kind of cone shape, but it's not straight sides. Let's go on to another problem. Notice that the boundaries have changed. We are working with e to the x, y equal to 0. And we're going to take a look at the volume that's created from x equal to 0 to x equal to 3. So here's the boundary, and it's going to go all the way around, And again, we're going to take one little rectangle perpendicular to the x-axis, and it's going to create this disc. And this disc is, again, a cylinder, and the thickness is delta x. So let's go ahead and continue finishing the problem here. So this is going to be, the radius will be the y of the upper minus the y of the lower squared, and then delta x. Now the y of the upper is our exponential, which is e to the x. Our y of the lower is y equal to 0, which I won't bother saying minus 0, squared delta x. Okay, and now we can set up our volume. And all of these little discs are going to go from x equal to 0 to x equal to 3. And we have pi e to, and if you want to simplify, e to the 2x, and then dx. And then here's the setup for our volume. All right, let's take a look at this line. And these are our boundaries. So it's the x-axis, y-axis, and then this line, so this region right here. But this time we are going to revolve around the y-axis. So our little rectangles are going to be perpendicular to the y-axis, and when they revolve, go all the way around, they're going to create a disc, but the disc is going to look like this, not the way it's done before. So let's go ahead, and here's our volume for a cylinder. Delta V equals pi, and we are not going to work with y of the upper and y of the lower. We're going to work with x on the right minus x on the left, quantity squared, and then this should be delta y instead, because our little thickness is delta y. All right, and so now I'm going to have to go over here and I'm going to have to solve for x here. So y equals 4 minus 2x, and I'm going to have to solve for x. I'll bring 2x to this side, and then I'll have 4 minus y, and then I'll divide both sides by 2. So this will be 2 take away y halves. So now I have a representation for x on the right. X on the right looks like that. So I'll go ahead and write that 2 minus y over 2. And then x on the left, we're stopping here at x equal to 0. I won't bother to write that. Squared delta y. All right, now I can set up my integral, and the y's are going to go from 0 and up to here where it crosses the y-axis, and this point is 0, 4. This is 0, 0. And I'm looking at y's because that's my variable of integration. So this will be 0 to 4, and then this will be pi 2 minus y over 2 squared delta y. And here's my representation for my volume. And that will be a cone, and because once this revolves all the way around, we're going to have that cone look. So we really could have figured out this volume without calculus. Let's look at something different now. We now have a curve here, an area. Two curves are meeting, and we have an area here, and we are going to rotate it about the x-axis. So rotating about the x-axis, something's going to happen. We're not going to get we're going to get a hole, some space inside. And let me go ahead and go to an animation to show you. So here's our picture right here, and here it is in kind of a 3D rendition. And what I'm going to do is I'm going to take this rectangle right here, and I'm going to revolve it. It's going to go all the way around the x-axis. So let me go ahead and show the revolution, and you can see as it goes around, it's going to have a hole inside. And so we don't call that a disc, we call it a washer, because there's a hole inside. And we're going to take all of these washers, and they're going to go side by side, and they're going to create the volume that we want here. So let's go back. And now I'm going to take a look at the representation here. So to figure out the volume of this, the area of the base is really the area of a big circle minus the area of the small circle, and then the thickness will be delta x. So since r is being used for both circles, I'm going to use capital R to represent the longer radius. So let's go ahead and go to let me go ahead and draw this. So let me go to red. All right, and so this will be my big radius, capital R, and then from the radius to the lower curve, I'm going to call that little r. So that's what the big R and the little r are going to be. All right, let's go ahead and set up the problem. So a little piece of volume will be equal to pi. I'm going to get the big circle minus the little circle. So it'll be pi, and my big radius will be y of the upper minus y of the lower squared. And then it'll be a delta x, and then that'll be that'll be the volume of this big, and then I'm going to want to take away the volume that's created by the hole. So this will be pi of y of the upper minus y of the lower quantity squared, and then delta x. So I'm creating two discs. A disc for the top one, and then a disc inside where the hole is being taken out. So then now I'm going to have pi, and then y of the upper will be, this is the upper value right here, the root x. And then that radius is y of the upper and y of the lower is down here on the x-axis, a minus 0. I'm not going to bother to write it. And that's delta x. So this is going to be the volume when I'm working with the big radius. And then the volume with a little radius will be y of the upper, which is the square, x squared, and the y of the lower is the x-axis, that's minus 0, and then delta x. Okay, so I have two volumes, a volume to create with a big radius and a volume with a little radius that I'm subtracting. Okay, so the volume is equal to the integral, and all our delta x's are going to go from 0 to 1. That's the point that they have in common, 1, 1. And so this will be pi. And if you want to just simplify x dx minus integral from 0 to 1 pi x to the 4th dx. And that'll create the volume. Now, there is also another way you can do it. If you don't want two separate integrals, you can actually just put them together, put the pi outside, and then just work with the squaring of the big radius minus the little radius if you want to work with just one integral. Remember, capital R is the radius to the outside, and little lowercase r will be the radius to the inside. All right, let's take a look at another problem. And what we're doing here is we have a curve and a line, which creates this area right here. And what we're going to do is we're going to revolve around the y-axis. So we have perpendicular to the y-axis. When we revolve, we're going to create a washer, which is a hole in it. And I think what I'll do is I'll set up one integral instead of what I was doing before. So I'm going to set up my little piece of volume. And that's going to be equal to, I'm just going to write pi, because they both share a pi, and then I'm going to write the big radius squared. So the big radius will be the x of the right here, x on the right, minus x on the left, quantity squared. Now this x, let's go ahead and make sure you understand. This is going to be our big radius here, and this will be our little radius here. So our big radius is x on the right minus x on the left squared, minus x on the right for my little radius, x on the right, x on the left, quantity squared. And that is representing the area of the base, which is the two circles being subtracted, and then the thickness will be delta y. Okay, let's go ahead and see if we can substitute these numbers here. The big radius right here, we need to go ahead and solve for x here. So I'm going to do y minus 1 is equal to x squared, and then x will be equal to root y minus 1. And this is the quadratic, and the quadratic is going to be my big R. And then when I solve over here for my my line, I'm going to have, let's see, y minus 1 is equal to 2x, and therefore x will be equal to y minus 1 over 2. And that'll be the x that I'm concerned about for my little r there. Okay, so let's take a look at our big R. Big R will be, I've already decided, it's root y minus 1. And the x on the left is right here. It's the y-axis minus 0. I'm not going to bother. Squared minus. And the little radius here is what I'm concerned with for this one. So that is, I've decided it's y minus 1 over 2 quantity squared. And I forgot to say minus 0 because it's along here on the axis. And then that's delta y. Okay, so make sure you are, I probably should have written here little r. so that you didn't think it was the same radius here. So let's go ahead. X on the right was the little radius when I was going to the x to the right. Okay, now the volume will be equal to the integral. And remember, I'm concerned about y's. So remember, it started at 1 and it went all the way up to 3. And because I had solved the intersections. So 1 to 3, and it's pi. And then it'll be, again, if you want to just simplify, you can. And then we can just leave this the way it is. Y minus 1 squared, half squared, and then delta y. All right, and there is some simplifying here that we could do, or we could just leave it that way. All right, this is the end of the screencast.